Today, we're going to dive into a really fascinating and maybe even a radical new way to think about how hallucinogens work. But it's actually bigger than that. It's a new way to think about how our own minds work as this delicate, constant balancing act between two really fundamental forces. So let's just start with a huge question. What if everything you think and feel, everything from your deepest focus to just a wandering daydream, what if all of that is powered by a constant negotiation happening inside your brain, a negotiation between joy and pain?
Now, to really get a handle on this new idea, we've got to ground ourselves in something a little more familiar first, those powerful substances that are known to completely alter our sense of reality. Of course, we're talking about hallucinogens. The clinical definition is pretty straightforward. They're drugs that mess with our reality. But what's actually going on under the hood? What's happening in the brain?
Just look at the sheer variety here. An LSD trip can last half a day, but a salvia experience can be over in just a few minutes. And you've got the intense feelings of intimacy from MDMA versus the complete dissociation you might get from ketamine. So how can one single class of drugs produce such wildly different effects? Well, that's the puzzle we're here to solve today.
To do that, we're going to need a new lens, a completely new model for understanding what's happening deep down in the brain's circuitry.
And that lens is something called the Brain Kinematics Model, or BKM for short. And it proposes something that's actually quite elegant, that the brain is always trying to balance itself on this fundamental axis between joy and pain. Think about it like a tightrope walker, right? Constantly making these tiny little adjustments just to stay centered.
And here's the core idea in action. A healthy mind, it's like that skilled tightrope walker, making quick, small, adaptive corrections to stay upright. But in a state like addiction, for example, those corrections become these huge, slow lurches from one extreme to the other, and that completely destabilizes the whole system. So what are the chemical players in this big balancing act? Well, pushing us toward that joy pole is the one everyone's heard of, dopamine. Pulling us toward the pain pole are these stress chemicals like substance P. And then you've got the regulators, like serotonin and GABA. And they're kind of like the referees, They're trying to keep the game from getting totally out of control.
Okay, so we have the theory, right? A balanced system of chemical push and pull. So let's apply it and see what actually happens when that delicate balance is broken.
Let's take a really common, real-world example. I think we've all heard people report that different strains of cannabis can have opposite effects. One might make you feel energetic and super talkative, while another just makes you quiet and want to sit on the couch. But why?
Well, the BKM offers a really fascinating explanation for this. An energizing strain actually increases the amplitude and the frequency of the brain's oscillations, and that leads to a surge in mental energy. A sedating strain does the exact opposite. It dampens the whole system, slowing everything down. See? Both are pushing the brain off its balance point, just in completely opposite directions.
So here's the crucial point to take away. Hallucinogens aren't just creating something out of nothing. What they're really doing is hijacking a natural system, this joy-pain balancing act, and pushing its oscillations into these extreme, unstable states that are far, far beyond what the brain is normally designed to handle.
Okay, now this model gets even more powerful because it doesn't just apply to drugs, it actually offers a framework for understanding the fundamental states of the human mind itself.
To really illustrate the extremes of this model, the source material uses its own specific terms for two opposite states. On one side, there's what it calls peaceful mentation. This is characterized by balanced chemistry in those nice, stable, high-frequency oscillations. On the complete other side is a state it labels criminal mentation, which it links to dysregulated chemicals and those big, unstable oscillations we were just talking about. The source uses this really stark contrast to show a system in balance versus one it defines as dangerously distorted.
And all of this, well, it leads to a really critical and maybe even a little bit of an unsettling question about our own minds. How much control do we actually have?
So this model proposes two states. In one, the brain is the dominant center. It's in the driver's seat making those small, flexible adjustments to maintain balance and autonomy. But in the other state, the brain becomes what's called an enslaved system. Here, the oscillations are so large and so destabilized that the brain can't correct itself anymore. It's just passively reacting, basically trapped in addictive, delusional, or compulsive loops.
So how does a brain cross over from one state to the other? Well, it all starts when a really powerful external force, like a drug or chronic trauma, is introduced. This pushes those oscillations way, way out of whack. And if that push is strong enough, or if it lasts long enough, the brain's ability to self-correct,
just breaks. And at that point, it's not in charge anymore. It becomes locked into this new dysfunctional pattern.
It really all comes down to a single idea: the threshold. This is that tipping point where the brain's natural resilience just fails. You cross it, and the system loses its autonomy, its ability to find its way back to the center.
Which leaves us with a final thought to chew on. You know, we all like to believe that we're in complete control of our own minds. But this model suggests that our control is conditional, that it completely depends on maintaining a really fragile balance. And it makes you wonder, when your brain is truly pushed to its absolute limits, who or what is really driving?